Good day, students. I am Sir Raymond, and today is another chance to learn math, so make sure to watch the entire video. In this video, we are going to talk about sum or difference of cubes. In this factoring method, we are still dealing with binomials, but this time, we are dealing with cubes. But before that, let's compare first a perfect square to a perfect cube. A perfect square is a product obtained when a number is multiplied by itself, whereas a perfect cube is a product obtained when a number is multiplied 3 times. Example of perfect squares are 1, 4, 9, 16, and 25. Because these numbers here, 1, 4, 9, 16, and 25 are products of a particular number multiplied by itself. For example, for number 1, we have 1 times 1. For 4, we have 2 times 2. For 9, we have 3 times 3. For 16, we have 4 times 4. And for 25, we have 5 times 5. When we talk about perfect cubes, these are 1, 8, 27, 64, and 125. Because these numbers here, 1, 8, 27, 64, and 125 are products of a number multiplied 3 times. For example, we have 1. 1 is a product of 1 times 1 times 1. For 8, we have 2 times 2 times 2. For 27, we have 3 times 3 times 3. For 64, we have 4 times 4 times 4. And last but not the least, 125, we have 5 times 5 times 5. So as you can see, that's what makes a perfect square different from a perfect cube. So it's the number of times a certain number is being multiplied, but the idea is the same. Now let's talk about sum or difference of cubes. In here, you will need to memorize the following patterns. For sum of cubes, you will have to take note of a cube plus b cube equals quantity a plus b times quantity a squared minus ab plus b squared. So take note of the arrangement of the operations. Plus, minus plus. Whereas for the difference of cubes, we will have to follow a cube minus b cube equals quantity a minus b times quantity a squared plus ab plus b squared. Again, take note of the arrangement of the operation. Subtraction, addition, addition, minus, plus, plus. Let us have example number 1. Let us now apply the patterns. Example 1. Factor x cubed minus 27. As you can see, the given is a difference. So therefore, the pattern that we are going to make use of is for difference. So it's the quantity a minus b times quantity a squared plus ab plus b squared. The first thing that you have to know is that this x cube represents a cube, and this 27 here represents b cube. And therefore, we will have to get the cube root of x cube and 27 first, because we need to find the value that should represent a and b. If you do not know, this a is the cube root of a cube, and this b is the cube root of b cube. So again, we'll have to get the cube root of x cube first, which represents the a cube, and then afterwards we'll get also the cube root of 27, which represents the b cube. So think of a factor that is when multiplied 3 times to itself will get x cubed. So definitely it's going to be x times x times x. Whereas for 27, think of a number that is when multiplied 3 times to itself will get 27. And as discussed earlier, that's 3 times 3 times 3, because 3 times 3 equals 9, and then times another 3 will get 27. So therefore, for x cubed, the cube root will be x, and for 27, the cube root will be 3. Now, all you have to do is to take note that a is equal to x and b is equal to 3. Now that we have the values for a and b, what's next to do is to substitute these to our pattern. Okay? So let's first have the first quantity. So a will be replaced by x, and then b will be replaced by 3. Now let's have the second quantity. So a squared, meaning x squared, plus a, which is x, so x times our b, which is 3. And then finally, plus b squared, which is again 3. So 3 squared. Now, what's left to do is to simplify this part. So copy the first quantity, x minus 3, and then evaluate this part. So for x squared, you will just have to copy, and on this part, you will multiply. So that's 3x, and 3 squared will get 9. So this is our final answer. Now let's have another example. Example 2. Factor 64x cubed plus 1. Well, as you have noticed, the operation is addition. So the pattern that we are going to use is for sum. And that's a cube plus b cube equals quantity a plus b times quantity a squared minus ab plus b squared. Again, this 64x cube represents a cube, and this 1 represents b cube. So just like what we did on the first example, we will have to get the cube root first of 64x cube representing a cube, and then we'll also get the cube root of 1 representing b cube. So let's do that. 64x cube and 1. As you have noticed, we have a numerical coefficient here, 64. So we will have to get the cube root of 64 first before identifying the cube root of x cubed. So what number that is when multiplied to itself 3 times will give 64? Again, this has been given earlier, and that's 4 times 4 times 4. Well, for x cubed, we know that this is x times x times x. So therefore, our a is 4 and x, or simply 4x. While our b, which is the cube root of 1, will also be 1, since 1 is a product of 1 times 1 times 1. So therefore, our b, as I've said, is 1. Now, what's left to do is to substitute our a to the pattern, and of course our b. So let's first have the first quantity. So that's 4x plus 1. And now the second quantity, we have 4x squared minus a So that's 4x times b, which is 1. And then finally, our b squared, which is 1. So 1 squared. Now, evaluate this part or simplify. So, copy 4x plus 1. And then evaluate this part. So, distribute the exponent to 4 as well. So, that will be 4 squared, meaning 16. And then x squared minus, evaluate this part or simplify. So that's 4x. And then finally, 1 squared, meaning 1. Just make sure that you have simplified this part very well so that if you're done with it, you already have the final answer. So that's it for our second example.